Hey YouTube, and welcome to Tech Query. Today I'll be going over an open source serial terminal I've made that is useful in testing and communicating with embedded system devices over UART. I work full-time as a software engineer working on embedded system products. In order to test that the products I work on are functioning properly, it's helpful to be able to communicate with them over serial and also get debug prints from the devices. A great program for doing this is called DocLite. At my work, I've used it many times when I was provided a license. And as you can see here, it's great for just creating quick command scripts and sending them over serial. However, if you want to save your command scripts, you do need a paid license for DocLite. And while I did have this on one computer at my work, unfortunately, we are getting new laptops and I will not be provided with a new license. Realizing I would no longer have access to a tool that I deem very useful, I decided to make an open source equivalent. Of course, this won't have all the features DocLite provides, but it will have most of them, and at least the ones I use regularly. So, for the rest of this video, I will go over how to use my open source program, which I have called deBUGger. For demonstration purposes, I'm going to be communicating over serial between my laptop and a Raspberry Pi. To connect with the Raspberry Pi, I'll be using a USB to UART bridge. To connect the bridge to the Raspberry Pi, I've used jumper wires to connect the RX and TX pins on both the GPIO pins on the Raspberry Pi and the edges of my USB to UART bridge. Also note, I have enabled UART on my Raspberry Pi. This is making a small edit to the config file within the Raspberry Pi directories. On the Raspberry Pi itself, I'm going to have a Python script running that will send back any serial commands I send to it. Also, once every 10 seconds, it'll send a debug print over the serial. Now on to the tutorial. First, I'll go over how to make a clone of the open source repo, which also includes the executable used to run the program. First, go to my GitHub page. A link will be provided in the description of this video. Once there, copy the link of my repository and open git bash on your local PC. Type git clone, then paste my link. Hit enter, and the repository will be cloned. Once the full repository has been downloaded, you should have all the source code, which by the way is written entirely in Python, and you will also have the executables in an exe folder. Click on the executable to open the GUI. Note that if you have an antivirus software, it may want to scan the executable, as mine is doing here. After a few seconds though, it should determine that the executable is not a threat, you can proceed with using the program. With the GUI open, we can now begin serial communication with the Raspberry Pi. On the top right of the GUI, there are several options for editing your serial settings. To choose the device you want to connect to, there is a drop-down menu of available serial devices. Choose the device that you want to connect with. After choosing my serial device, I am now ready to send serial commands. On the left-hand side of the GUI, there is a list of serial commands I can send. These were pre-created so I could demonstrate the GUI's ability for this video. I'm now sending individual commands by pressing the farthest left arrow buttons. Notice that the value I am sending over serial, what I am transmitting, and the bytes I receive back as the response are all being printed into a transaction log in the middle of the GUI. For this initial demo, all the bytes were written in decimal format. However, we can actually change this by changing the byte format with the drop-down menu on the right-hand side of the GUI. Notice here now I'm changing it to ASCII, where I can actually see that, hey, some of these byte commands were actually ASCII messages all along. And now I can send those over my serial terminal. We can change how long we listened for a serial response by modifying the time interval setting under the serial settings. This number is the timeout for listening over serial in seconds. Increasing this number means we will listen for a longer interval of time for a response. But what if we don't want a serial timeout, and instead want to continuously listen for incoming serial traffic? That's where listen mode comes in. By pressing the listen button on the top of the GUI, you will notice that there is a little debug print that shows listen mode active. Once listen mode is active, we can continuously receive any debug prints coming from our serial device. In this case, it's our Raspberry Pi, which will once every 10 seconds send a debug print, as well as returning any messages we send over serial. During listen mode, you can also type out commands directly to send to your serial device using the text box at the bottom of the transaction window. Just type out what you want to send to your serial device and press the send button. Rather than having to press each button to send your commands, you can loop through your entire command list by pressing the loop button on the top of the GUI. To save what has been written into the transaction log, press the Write to File button on the top of the GUI. This will allow you to store the transaction log as a text file. Probably the most useful aspect of this deBUGger GUI is the command list and your ability to edit the command list at any time. By pressing the Edit Command List button, a new window will appear where you can add and remove serial commands. The serial commands in your command list and all your serial settings, such as baud rate, serial COM port, and time interval, are all stored into a JSON file called a profile. When you modify the command list or your settings, if you hit the Save button, it will update the JSON profile that you are currently using. If you want to save your changes to a new JSON profile, simply click the Save as New Profile button, and this will allow you to create a new JSON profile. If you want to switch to another JSON profile, simply press the Switch Profile button. This will allow you to search your file directories for your desired profile. If you have additional questions on how to use this GUI, or have interest in modifying the code for your own purposes, check out the README file included in the repo. This goes over into hopefully more detail how to use the program, and also some helpful hints when you are modifying the code. I apologize if the code is a little messy, as this was my first time actually writing a GUI. Let's go over some challenges you may face in trying to use the serial debugger. If you're cloning from GitHub on a corporate computer, your corporate firewall may see the exe file as a threat and try to delete it. I've observed this at my own work. So instead, I actually copy the exe file from my home PC using a flash drive and port it over to my work computer. Using this method has prevented my work's firewall from attacking it. Again, if you are on a corporate computer, I have found that in order to actually use the serial ports, I need to run as administrator. This is not the case on typical home computers, but again, with corporate offices, I believe this will be required. You need to have your display be sized to 100% scale, and hopefully you have a monitor that is able to support 920 by 1080 resolution. If this is not the case, I apologize, but I'm afraid this program is not for you. However, you can modify the code yourself if you would like. In future GUI projects, I'll be sure to be mindful to make my GUIs easier to resize. This issue was largely due to my inexperience in writing a GUI and not thinking to support different monitor layouts. Well, I hope at least some of you will find this program helpful, whether it be for debugging your embedded systems projects or just having a new serial terminal. All of the source code is written in Python. In the README file, I explain what libraries were used to create the program. But the main one to note is all the GUI was written using the tkinter library, which is included with Python 3. Hopefully the source code could be a good reference for any other GUI projects you may be working on. Please let me know in the comments below if there are any recommendations on how I could improve my videos. I will try to update this channel occasionally with any open source projects I work on. Until the next video, I wish you all the best of luck and stay safe.